Buonasera.
Good evening. I'm going to speak in Italian, sorry, or possibly it's better in English.
You're permitted to speak
I'm
Italian.
permitted to speak Italian. So just a small introduction in Italian, then I switch to English for the event. So just, allora niente, vi dicevo che io sono contento di essere qua in questa bellissima Aula Magna, in coda a quella che è stata l'Assemblea Generale della Società Geologica e il Consiglio Direttivo della Società Geologica. Stiamo riprendendo da quest'anno la possibilità di avere eventi importanti, sempre in coda alle assemblee delle sociali, eventi importanti che richiamino ovviamente la divulgazione delle scienze geologiche, delle scienze della Terra. Questo è importante per noi perché proprio l'attività di una società è proprio la primaria attività di una società è la divulgazione della scienza, di una società scientifica, la divulgazione di una scienza. Siamo qui insieme a altre società, ovviamente. Tutto questo, innanzitutto io ringrazio l'APPI, che è la Società di Paleontologia Paleoarte Italiana, rappresentata dal presidente che è Anna Giamborino, e che quindi ci ha creato poi tutti questi contatti. Ringrazio l'UTET che ha permesso la possibilità di avere Stephen Brusatte qua. Ringrazio il Dipartimento, perché il Dipartimento di Scienze dell'Università di Roma Tre ha dato l'opportunità di avere questa bellissima aula, e fondamentalmente il Dipartimento fa il professor Kotsakis che lo rappresenta, e poi ringrazio anche la SPI, perché la SPI in questa, cioè la Società Paleontologica Italiana, è anche lei ovviamente in questa avventura, diciamo, di queste conferenze che stiamo facendo. So Steve, I was just introducing the fact that you're here just because APPI and UTET, they were organizing everything for you, but Italian Geological Society has this important days today here, and has a tradition. Italian Geological Society had at the end of the General Assembly usually an event that's divulgate the science, or geological science, or earth sciences, or geosciences, as you want to say. I thanks also the Department of Science of the University of Roma Tre that's allow us to have this beautiful room, and Professor Kotsakis is representing the department.
I am retired. There is the next head of the department there, and the coordinator of the section of Geologica there, and the people who organize it.
And I thanks also the Paleontological Society of Italy that's represented here by Professor Raffaele Sardella. So that's, I'm going to give the...
Cambio. Buonasera e benvenuti a tutti. Io rappresento appunto l'Associazione Paleontologica Paleoartistica Italiana, l'APPI, e inizio con i ringraziamenti. Ringrazio sicuramente l'Università di Roma Tre per l'accoglienza, ringrazio l'UTET per la bellissima occasione, e ringrazio il professor Steve Brusatti, ci tiene a precisare, la pronuncia deve essere italiana, per l'estrema disponibilità. Abbiamo avuto modo in questi giorni di conoscerlo un pochino meglio, ed è una persona veramente molto 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 disponibile. E mi accodo un po' al discorso del professor Conticelli, l'importanza della divulgazione delle scienze naturali in generale, delle scienze geologiche, che noi sposiamo molto bene come mission, e soprattutto il nostro intento è quello appunto di creare un network, una rete anche tra le stesse associazioni. Quindi la giornata di oggi è per noi molto molto importante. Ringrazio tutti, non voglio rubare altro tempo e lascio la parola ai colleghi. Grazie.
ormai siamo diventati esperti di cerimoniale. Allora, io sono qui in rappresentanza della Società Paleontologica Italiana, della Presidente Lucia Angiolini, lo so, vi è capitata la mia persona, pazienza insomma, per voi. In realtà sono qui quindi che porto i saluti di tutto il coordinamento, il vertice della Società Paleontologica Italiana per un evento molto importante e in una scia, come è stato detto già in precedenza, di apertura al grande pubblico con presentazioni di libri o di eventi comunque di straordinari da questo punto di vista. I dinosauri sono una tematica caldissima, sono una tematica che accende l'interesse di per sé, ma che è fondamentale vengano veicolati in maniera corretta, scientificamente e aggiornata. Il libro in questione rappresenta una mirabile sintesi, lo dico col cuore, da lettore prossimo venturo, ma l'ho già potuto vedere un pochino, è una mirabile sintesi delle nuove scoperte, delle nuove ricerche, delle nuove idee sui dinosauri, sulla loro origine in particolare, e il fatto che un paleontologo del terzo millennio, della nuova generazione di paleontologi, usi poi il libro, ne abbiamo parlato prima tra di noi, è anche molto bello perché il libro continua a essere un elemento, nell'era di internet, comunque un elemento di riflessione, che suscita l'entusiasmo, e i dinosauri presentati così, come dire, provocheranno parecchi paleontologi nel futuro, credo, temo, spero. Io ho avuto una folgorazione del genere a 11 anni, i dinosauri per colpa, purtroppo qualcuno si potrà lamentare, ma è bellissimo che ci sia ancora qualcuno che la ricerca la traduce per un grande pubblico, con la passione, con l'entusiasmo e con la competenza. Grazie a voi per aver organizzato la cosa e sono molto contento, ve lo dico sinceramente, di essere qui, vedo tanti amici e tante persone dopo parecchi anni. Ecco la parola a Tassos.
Ma io non rappresento, in realtà, come ho detto prima, sono in pensione, però siccome continuo a frequentare e a fare un po' di ricerca, a nome di Roma Tre noi ringraziamo il professor Brusatte di essere qui. Come dicevo prima, io non sono un paleontologo di dinosauri, mi occupo di organismi molto più piccoli, roditori, insettivori, però ho avuto occasione tre volte di incontrare il nome del professor Brusatte. La prima è stata nel 2012, quando ho letto il primo libro, che è stato Paleobiology of Dinosaurs, ed era un libro tecnico per specialisti per i dinosauri, però io l'ho utilizzato, qualche piccola parte, per il corso di paleontologia dei vertebrati. Una seconda volta, un anno e mezzo fa, quando alcuni colleghi dell'Università di Cambridge e del ex British Museum, adesso Natural History Museum of London, hanno proposto una filogenesi dei dinosauri un po' differente, e un gruppo di paleontologi, fra i quali anche il professor Brusatte, hanno replicato sempre su Nature, proponendo di mantenere la posizione classica, ortodossa, chiamiamola, della filogenesi dei dinosauri. E la terza volta, 2 mesi fa, quando ho visto il suo libro The Rise and Fall of Dinosaurs, questo qui. E ho visto adesso che c'è anche una traduzione in italiano, il che mi fa molto molto piacere, perché passare non solo alla pubblicazione scientifica, ma anche alla divulgazione che possa entusiasmare, perché da quello che ho letto nella edizione inglese veramente attira. Probabilmente attira anche un vecchio come me, però immagino molto di più i giovani. Dunque ringrazio tutti quelli che hanno organizzato questo pomeriggio, questa conferenza, e ovviamente prima di tutto il professor Brusatte. Thank you very much.
Allora, diamo il via a questa conferenza, vi lasciamo in compagnia del professor Brusatte e buon ascolto.
Okay. Shall I use this one?
Yeah? Good. Okay. Well, grazie. Thank you very much for all of this introduction, and buonasera. Very good to see all of you here on a Friday afternoon. I will apologize for having to do this talk in English. It is very embarrassing for me to not be able to speak some Italian to you. I have Italian family heritage, but my family moved to America from Milano and Torino many generations ago in the late 19th century. So they did not teach any Italian to my father, so I blame him, basically. So I will give the talk in English, and of course I want to take any questions anybody has after the talk, but if you would like to ask questions in Italian, I'm sure some of our friendly folks here can translate for me. Okay, all right, now, I'm one of those fortunate people that gets to dig up dinosaurs and study dinosaurs for my career. So like several people here, I'm a paleontologist. And I'm from America. I'm from the Chicago area. But I now live in Scotland. And I've been teaching at the University of Edinburgh, beautiful historic university in Scotland's capital, for about 6 years now. And it's a wonderful place to study paleontology. It's the place where geology as a field, of course, started with James Hutton many, many centuries ago. Now, I have the new book out, and it's been wonderful being in Italy this week, getting to meet many people and speak to many people about the book. And what I want to do today is basically tell the story that I tell in the book, but in a much briefer way. I want to tell the story of the rise and fall of the dinosaurs. So the story of the dinosaurs. So where dinosaurs came from, and how they began to evolve, and how they spread around the world and got bigger, how they dominated the world, really as an empire, for over 150 million years, and then of how some of them still continue today, but most of them, of course, died out very quickly. So this is a story, again, over 150 million years, and I'm going to try to tell this story in about 45 minutes. So, instead of wasting more time with small talk, let's just jump into the story. Okay, so let's start at the beginning. Not at the beginning of the Earth, but let's go back to about 252 million years ago, at the end of the Permian period. And this is when the Earth looked like this, very different from today. This was the time of the supercontinent Pangaea. And now, about 252 million years ago, beautiful lighting, by the way. It's great. I feel like some sort of actor on stage. 252 million years ago, the Permian period ends with these supervolcanoes erupting in what is now Siberia. And for 5 million years they erupted, and they brought with them all of these poisonous gases, carbon dioxide, methane, these gases that led to global warming. And that caused an enormous mass extinction, the biggest extinction ever in the history of the Earth. Maybe up to 95% of species died out. But those volcanoes stopped erupting, and when they stopped erupting, the Earth started to recover. And as the Earth recovered, you had those few surviving animals now free to evolve in a new world, in a largely empty world. And so when I was a student, I became very interested in this extinction, in what lived and what died, and specifically what evolved afterwards. And so I did a lot of field work in Poland for several years, maybe not a place you think of when you think of digging up dinosaurs, but there's lots of quarries in Poland where they mine clay to make bricks, and these layers of mudstone, layer after layer, are full of fossils. Fossils from the Permian into the next period of time, the Triassic period, and those layers, you can read them like the pages in a book and study those fossils to understand the extinction and the recovery. Now, the fossils in Poland are not so much skeletons or bones or teeth. They're not so much parts of the animals, but they are the things that the animals left behind. So these layers are full of footprints that were left by many different creatures. And in rocks, only about 1 million years after those volcanoes were erupting, we start to see these prints here. And this is actually what we have is a footprint, but also a handprint. And these were left by a small animal just about the size of a house cat that walked on all four legs. And it was an animal that would have looked something like this. Maybe a very funny looking animal with those long arms and legs, very skinny body. But this animal was a reptile, and this animal could run very fast on those long legs. And really what we're looking at here is not just a normal reptile. What we're looking at is the start of the dinosaurs. Dinosaurs evolved from this type of animal that was living right after that extinction. And so this animal looks nothing like a T-Rex or nothing like a Brontosaurus. Those dinosaurs would come much later. But instead, dinosaurs had a very simple beginning, a very humble beginning. Really, like any empire, they had to start somewhere, and they started here. And these animals were not very special, to be honest. They were living in a world where they were not the dominant animals. They were not at the top of the food chain. But instead it was other animals that ruled the Triassic world. And so we also did a lot of field work in Portugal, trying to find fossils of these animals. And in Portugal, we found a fossil site with over 100 skeletons, so a mass graveyard of the sort of animals that were ruling the rivers and the lakes during the Triassic period, when those first dinosaurs were evolving. And these animals were not dinosaurs. They were these type of creatures. They were amphibians, giant amphibians. Basically, they were salamanders the size of small cars. And hundreds or even thousands of these things lived together. They formed big flocks in the water. They had thousands of teeth in their mouth. They would have been very nasty creatures. So if you were one of these first small dinosaurs, you would want to avoid the water. But you would also not be very safe on the dry land, because the Triassic on land was the age of crocodiles. There were all sorts of ancient crocodiles and their close relatives that were very different and much more diverse than today. So you had crocodiles almost the size of buses. You had crocodiles with horns and armor. You had crocodiles that ate plants. You had crocodiles that had sails on their backs. You had crocodiles that lost all their teeth and had beaks. You even had crocodiles that only walked on their hind legs. So it was these animals that ruled the land. These were the competitors of the first dinosaurs, and they were much more dominant, much more successful than the dinosaurs. But obviously, something then changed. And what happened was, about 200 million years ago, at the end of the Triassic period, that supercontinent began to split apart. So Pangaea began to break up, and this is why we have many smaller continents today. But as Pangaea started to break up, it first started to split along what is now the Atlantic Ocean coast. So between North America and Europe, and then later between South America and Africa. And as the land broke apart, you had volcanoes erupting through those cracks in the land. And once again, these volcanoes caused global warming, and they caused a big extinction. And this time, maybe about 70% of all species died. Those crocs were decimated by this extinction. Almost all of them died. The only ones that survived were those few species that gave rise to the modern crocodiles. And those giant car-sized salamanders, most of those died too. But the dinosaurs did not. The dinosaurs were not affected very much by this extinction. They just passed right on through from the Triassic into the next period of time, the Jurassic period. And we don't really know why. We don't really know why. And I always say, I wish we knew why. It would make this story so much better to have this part of it, to tell you exactly why the dinosaurs lived when the crocodiles and the giant salamanders died. But we don't know why. It's one of the biggest mysteries that still remains about dinosaurs. And there still are many mysteries, of course, about dinosaurs. So I always say this will be up to the next generation of paleontologists. I know we have many students here today, and I think you're going to figure that one out. And so when you come to Edinburgh to study, all right, we'll try to figure this out. But I really do think this is a big and exciting question. But we don't know the answer. What we do know, though, is somehow this extinction killed off the competitors to dinosaurs. Dinosaurs made it through, and then after the extinction, we're in the Jurassic period. There's a reason they call it Jurassic Park and not Triassic Park, because in the Jurassic is when you start to get dinosaurs like this. Those first small, humble dinosaurs now have a new world to themselves after the extinction. They spread around the world. Some of them grew into huge sizes, and they started to evolve horns and spikes and beaks and frills and all the other things we think of when we think of dinosaurs. These are the dinosaurs that we know and love. It's in the Jurassic when dinosaurs finally start to rule the world. And it's in the Jurassic when so many of the most familiar groups of dinosaurs evolved. It's when their family tree started to really diversify. And we are learning so much more about dinosaurs these days because we are in the middle right now of the most exciting time, I think, in the history of dinosaur research. People are finding more dinosaurs than ever before, and somebody around the world is discovering a new species of dinosaur on average once every single week. So that is 50 new species, give or take, every single year. And this is because paleontology has become a global science. The science has diversified. There's many young people, women, men, all over the world, not just in Europe and America, but in China and Argentina and Brazil, making these incredible new discoveries. We are even discovering dinosaurs, believe it or not, in Scotland, another place you might not think of when you think of dinosaurs. But the dinosaurs we have in Scotland come from the Jurassic period, and they help us understand how dinosaurs were getting bigger and spreading around the world and becoming dominant animals. There's only one place in Scotland where you can find dinosaurs, and that is on an island off the west coast of the country, a beautiful place called the Isle of Skye. And maybe some of you have been there. A very nice whiskey distillery there called Talisker. I think it's one of the most beautiful places in the world, these amazing landscapes here. But for us, we love it because there's dinosaurs, because it has the right kind of rocks from the Jurassic period. But it is a challenging place to work, because it's Scotland, it's cold, it rains every single day, it's windy, and all the rocks are along the coast, so we always have to be careful of the tides. So it's not the easiest place to work, but it's a great place to work, and one of the wonderful things is it's a place where I can take my students. So I train many of my students there. Some of you may know of Davide Fofa, who is from Italy, who just finished his PhD a few days ago. He graduated from the University of Edinburgh, so he's one of my students. I actually have many Italian students, including Marco's former student Sophia, who's just started in Edinburgh. So many of you remember this. We have a great master's program and a great PhD program in Scotland, and if you come and study with us, you get to go to these places. And you'll probably find the good fossils, because it's always my students that find the best fossils. I wish I found the best fossils, but it's always my students. And here is Amelia in the middle there, who found this amazing skeleton of a pterodactyl a few years ago on Skye, and she's looking at it there in the rock, and we've just started to study this fossil, which we're really excited about. So maybe in a few years I'll have more to tell you about this fossil. But, okay, our students get to do cool work on Skye. They get to play with cool tools here. This isn't a place where usually we can use our hammers and our chisels. The rock is too hard, so we have to cut the bones out. The small bones we can cut out with these little tools. The bigger bones, we need bigger tools. So the rocks are so hard that we need to use saws with diamonds on the blade to cut the bones out. All part of the fun of finding dinosaurs in Scotland. I want to tell you just one story of what I think is the most interesting discovery we've made. And we made this a few years ago, and Davide was part of the team that made the discovery. This is in the far northeastern part of the island. And I'm taking this picture on one of the few days where it is sunny, and I'm standing right by the ruins of a 14th century castle, looking across the beach. This is at high tide, but when the tide goes down, that beach turns into rock. And we went there to look for dinosaur bones, but instead we started to see these strange holes in the rock. And at first we didn't think so much of them. But then we started to notice that actually there were over 100 of these holes on that rock platform. And they were all pretty much the same size and shape. And then we started to see that there was a bit of a pattern. There was a bit of a left, right pattern, a zigzag type of pattern. Then we saw that if we looked at these things from the side, that they were actually impressed into the rock. So they must have formed before this was rock, back when it was still sand and mud. And then we saw some of these things were filled in with some other rock, harder rock, and that had some little projections on it, things sticking out, 1, 2, 3, 4. And then sometimes these things were paired together, and there was a big one, the shape of a horseshoe, and then a smaller one. And really, what stood out more than anything is just how big these things were. They were about 70 centimeters across, so that's about the size of a car tire. So after a little bit, we realized that what we were looking at was not just random holes in the rock, but these were actually footprints and handprints, but so much bigger than those tiny ones that we found in Poland. And that's because we're in the Jurassic now. Animals are evolving, and dinosaurs are getting bigger. And these, of course, are footprints left by dinosaurs, and there's only one type of dinosaur, in fact, only one type of animal that has ever lived that was so big that it would leave a hole the size of a car tire every time its hand or foot hit the ground. And I think you know what I'm talking about, these kind of dinosaurs. The big ones with the big bellies, the long necks, what we call the sauropod dinosaurs, those giant plant eaters, the dinosaurs like Brontosaurus, Diplodocus, Brachiosaurus, those sorts of animals. Now, the ones that made their footprints in Scotland were probably about 10 or 15 tons. And they were maybe about 10 or 15 meters long. They were very big for that age. But later on, these same dinosaurs in the Cretaceous period would become even bigger. And some of them would become as big as jet airplanes, as big as Boeing 737 airplanes, the Ryanair, the EasyJet type of airplanes, which is astounding to think about. A real animal the size of a jet airplane. So these were spectacular creatures. And more recently, my students have started to study them. So this is Paige. Paige is from America like me, but also like me, she has Italian ancestry. You can probably tell from her surname. Her family comes from the Genoa area. And Paige has a background in geology, but also in engineering. So Paige is very good with building things and using different tools. So Paige has been using drones to map these footprints. And not just that one site, but we found many other sites as well, including one that Davide Fofa himself found a few years ago. So we have several footprint sites, and Paige has been mapping them with the drones. That helps us understand how many footprints we have, how they're related to each other, how fast the dinosaurs were moving, and it also helps us understand the environment. And this is the environment that these dinosaurs were living in. They were making their footprints in a lagoon, in shallow water. And so I think you can start to see that in the Jurassic period now, things are really different. You have huge dinosaurs, and you have dinosaurs that aren't just living on the land, but they're spreading around so much that they're now living in new environments, even on the beaches and in the shallow water. And it's not only these giant long-necked dinosaurs that we have footprints of, we also have footprints of these type of dinosaurs. Much smaller, only about the size of a human. They only walked on their hind legs, so we only have their footprints. And we have some bones of these things as well, and we can tell they had sharp teeth and they had sharp claws, and they were, of course, then part of the great group of meat-eating dinosaurs, what we call the Theropod Dinosaurs, the group that includes T-Rex. And, in fact, these dinosaurs were primitive cousins of T-Rex. They were the very first tyrannosaurs. Now, in Scotland, we only have footprints, but in China, we have skeletons of these things, and this is what one of them looks like. Again, only about the size of a person. And a very strange head with this Mohican crest of bone on the top of the head, and longer arms and skinny legs. So, these animals, evolved into the great T-Rex. So how did that happen? Well, evolution made some pretty important changes. And we have a new clue a few years ago from a new species of tyrannosaur that was found in Uzbekistan in Central Asia. This is one that's a little bit bigger than the first tyrannosaurs. This is about the size of a horse, and we named it Timurlengia. So a little bit bigger. What we have is a very nicely preserved skull of this dinosaur. And this is looking at the skull from the back. This is where the spinal cord would go into the brain. So we have the brain cavity inside the skull, and that's really important because we can stick that skull into a CAT scanner and use the X-rays to build a digital model of the inside parts of the skull, including the brain and the ears and the sinuses. So this allows us to see what a tyrannosaur brain looks like. And this is what the back of the brain looks like. The front part is kind of broken. It's not so well preserved, so I don't show it here. But this is the back part of the brain in blue. This thing that looks like a pretzel is the ear. And there's two important things we can tell from this. First of all, this is a big brain for a horse-sized animal. This was a smart dinosaur. This dinosaur was not stupid like people used to say dinosaurs were. And we can tell from the long length of the cochlea of the ear, that's what hears sound, we can tell this dinosaur had a really good sense of hearing, much better than our sense of hearing. So it looks like tyrannosaurs were becoming more intelligent, were evolving better senses while they were still small, maybe so they could survive as they were living in the shadows. And then, a little bit later, the bigger dinosaurs of the day died out later in the Cretaceous period, and the tyrannosaurs took advantage of that, and they seized that niche in the food chain, the top predator role, and that's when you got T-Rex. T-Rex was the biggest, baddest predator that has ever lived on land in the history of the Earth. This was an animal the size of a double-decker bus. It had a head the size of a bathtub. It had more than 50 teeth in its jaws. Each one was the size of a banana, and it could bite so hard it would literally crush the bones of its prey. And then, yes, of course, it had the pathetic tiny little arms that are still such a mystery. What made T-Rex great was not just that it had sharp teeth and sharp claws, but what made T-Rex great is it had sharp teeth and sharp claws, but also it was intelligent, and it could hear and see and smell very well. It was that combination that made T-Rex such an important dinosaur and such an incredible dinosaur. So the combination of brains and brawn, that was the secret of the tyrannosaurs. T-Rex lived right at the end of the time of dinosaurs, in the Cretaceous period, the period that came after the Jurassic period. T-Rex lived in a world that looked like this. So as you can tell, the continents were continuing to move apart from each other. And dinosaurs were evolving and diversifying as the continents moved around. And as the continents split from each other, you got different types of dinosaurs living on those individual continents. Now, also during this time, some dinosaurs, like the tyrannosaurs and like the sauropods, were getting bigger. They were becoming huge. But there was another group of dinosaurs that went in the opposite direction, and they were becoming smaller. And these dinosaurs are some of the closest cousins of the tyrannosaurs, and they are also the only dinosaurs that still live on today. And yes, absolutely, you know what I'm going to say, we're talking about birds. So birds evolved from dinosaurs, and that makes them dinosaurs. And birds evolved from theropod dinosaurs. They fall into that group of meat eaters on the family tree. T-Rex is a very close cousin of birds. But the type of dinosaurs that birds actually evolved from are these types of dinosaurs, the raptor dinosaurs. So I think you probably know Velociraptor from Jurassic Park, very famous dinosaur. But like a few things in the film, the Velociraptor isn't quite right. It's not quite accurate. It's a bit too big, and it's covered in scales. It looks like a crocodile or like a lizard. But in real life, Velociraptor was only about the size of a small dog, and it was covered in feathers, and it even had wings. It would have looked much more like this. And this is not just some crazy hallucination of an artist. This is real life, and we know this from real fossils. We know this because over the last 20 years, and only over the last 20 years, people have been finding these amazing fossils in northeastern China. And these are probably, without doubt, the most important fossils of dinosaurs that have been found in my lifetime. And these are the famous feathered dinosaurs. Over 1,000 fossils of dinosaur skeletons. All the bones are there, beautiful bones, but also feathers all around the bones. And that's because these dinosaurs, their entire ecosystems were buried by volcanoes, kind of similar to what happened in Pompeii. And so that meant that all these dinosaurs were killed at once, and the feathers were preserved along with the bones. Now, the first ones of these were found in the late 1990s. Steven Spielberg didn't know about these dinosaurs when he made Jurassic Park, and that's why you don't see feathers on the Jurassic Park dinosaurs. Now, it's been a really great privilege for me to be able to work with some amazing colleagues in China to study some of these feathered dinosaurs. And this is just a quick picture from one of the museums I visited on a trip a few years ago. The fossils from China, they tell us some important things. They tell us about how feathers evolved, about how flying evolved, and about how birds evolved. The first major thing they tell us is that most dinosaurs, maybe even all dinosaurs, had some type of feathers. So this here, this is a tyrannosaur. This is part of the tail. These are two tail vertebrae of a tyrannosaur, and these things up here that look like scratches in the rock, those are feathers. Now, those are not the feathers of modern birds. These feathers are very simple. They look like hair. They're just individual little strands. And so these dinosaurs, they could not fly with those feathers any more than we can fly with our hair. Of course we can't do that. So these dinosaurs probably first evolved feathers to keep themselves warm, the same reason mammals evolved hair. So feathers did not evolve for flying. And most dinosaurs had these simple feathers. We even know that some plant-eating dinosaurs had them. But one group of dinosaurs started to change their feathers, and these were the raptor dinosaurs like Velociraptor. And these dinosaurs, they were getting smaller and smaller, and as they were doing so, they were packing those feathers closely all over their bodies. And on the arms, they were starting to line up their feathers, and those feathers were getting longer, and they started to branch out, and they started to get flat, until you had some raptor dinosaurs that had wings. That had actual wings. This is a wing on a raptor dinosaur. And these are the feathers there. And these feathers look just like the feathers of modern birds. They attach to the bones in the same way. This is a dinosaur with a wing. But this is not a bird. This is still a raptor dinosaur. And it's a dinosaur, a new species that I studied and described a few years ago with my good friend Junchang Lu, who very sadly passed away last month at a very young age, very tragically. He was one of China's leading dinosaur hunters and a real giant in the field, also a gentleman and a very good friend. Now, we studied this dinosaur together, and this is a picture of this dinosaur in all of its glory. Zhenwanlong is the name that we gave it. And again, this is a raptor dinosaur, covered in feathers. Feathers on the tail, feathers on the body, and here's one wing, and here's that other wing from a few slides ago. But here's something interesting. Zhenwanlong was about the size of a donkey. And those wings are not that big. So this dinosaur was too big to fly with those little wings. So that means that even wings did not evolve for flying. And we think now that wings might have evolved as display structures, basically as advertising billboards sticking out of the arms of these dinosaurs to attract mates or to intimidate rivals, basically doing what peacocks do with their tails. And one line of evidence for that is we can now tell the colors of dinosaur feathers if they're well preserved. We can see the little pigment vessels that held the color under really high-powered microscopes, and we can tell that the feathers of these first dinosaurs with wings, they were not boring colored. These dinosaurs were not just green or brown. These dinosaurs had all kinds of fantastic, flamboyant colors. So it looks like even wings did not evolve for flight. But we're getting very close to a flying animal here, because if you have a dinosaur like Zhenwanlong that has feathers and has wings, all evolution has to do, really, is make it a little bit smaller and make those wings a little bit bigger until you have an animal that can flap those wings and hold itself up in the air. And at this point, dinosaurs started flying. And at this point, we say birds have now evolved. So that means that birds are dinosaurs, because they evolved from dinosaurs. And I know that's a strange thing to think about. But when people ask me about this, I always give the analogy of bats. We all know bats. Bats are mammals. Of course bats are mammals. They have hair. They have the same teeth we do of, molars and premolars and so on. They have the same ears we do. They are mammals. They're simply a strange type of mammal that got small and evolved wings and developed the ability to fly. And birds are the dinosaur version of this. Birds are simply a strange type of dinosaur that got small, evolved wings, and developed the ability to fly. And that means that birds are still with us, that dinosaurs are still with us. There are over 10,000 species of dinosaurs alive today. Some of them are majestic, like our American bald eagle, and some not so much. But, and I love this joke, when you're at the beach, when you're trying to relax, you're trying to eat some chips maybe, and one of these bastards comes down from the sky, I think in that moment, the intelligence, the nastiness, the feistiness, you can sense the inner velociraptor in a seagull. But, okay, dinosaurs are still alive as birds, but all the other dinosaurs, the T-Rexes, the Triceratopses, the Brontosauruses, those things all died out. And they died out very suddenly, 66 million years ago, when the world looked like this. And at exactly this time, an enormous asteroid hit the Earth. This was not a normal asteroid. This was probably the biggest asteroid that's hit the Earth in the last 500 million years. This was a rock 10 kilometers wide. It was traveling faster than a bullet. It smashed into the Earth with the force of over 1 billion nuclear bombs, and it punched a hole in the crust over 100 miles wide. And that hole is in Mexico. The crater is in Mexico. As this asteroid hit the Earth, it unleashed a cascade of destruction. Fires, tsunamis, earthquakes, powerful wind, volcanoes erupting, all kinds of problems. And these things changed the Earth so quickly the dinosaurs could not adapt, except for birds, a few birds. A lot of you probably know this story. It's a very famous story, but I have to just mention it because I'm in Italy. The first evidence that this asteroid killed off the dinosaurs was discovered right here in Italy. It was discovered in the Apennines, in the small town of Gubbio. And this evidence was found by this geologist, one of my heroes, Walter Alvarez, in the 1970s. He was a young scientist, and he was studying the rocks around Gubbio. Some of these rocks were formed in the Cretaceous period. The ones above were formed in the period of time after the Cretaceous, called the Paleogene. And in between those rocks, marking the time the dinosaurs died, was this very narrow layer of clay, only about 1 centimeter thick. And that clay is the bookmark between these two great intervals of time. The time of dinosaurs and the time where dinosaurs, other than a few birds, are no longer alive. Walter analyzed that clay, and he found that it was full of a very strange chemical element called iridium. And there's a reason why most of us don't know about iridium. We all know about carbon and oxygen and all the well-known elements, but iridium we never think about because it's very rare on the surface of the Earth, but it is very common in outer space. And this was the first clue, a chemical clue, that an asteroid hit the Earth. And then a lot of other evidence piled up over the next decade until the crater was eventually found. We now know that this asteroid hit the Earth at a time when dinosaurs were still thriving. There were still many species of dinosaurs, meat eaters and plant eaters and big ones and small ones, living all over the world when that asteroid came down. Even T-Rex itself was there when the asteroid hit. And this asteroid changed the Earth so quickly that the dinosaurs couldn't cope. And we don't find any dinosaur bones other than birds in rocks after 66 million years ago. They're all gone. And so now I'm turning my attention as a researcher more towards what happened after the dinosaurs died. Of course, I'm continuing to study dinosaurs. It would be silly to not study dinosaurs anymore, but I'm very interested now in what happened once the dinosaurs died. And so I'm doing a lot of work in New Mexico. This is a state in the southwestern USA. And this is one of the best places in the world to find fossils of the last dinosaurs, but also fossils of the animals that are taking over from the dinosaurs. And we find these fossils in this beautiful scenery. Desert scenery, badland scenery, full of fossils. Now, this is also a place where I take my students, and I work very closely with my good friend Tom Williamson there in New Mexico. This here is Sarah, who is my first PhD student. Sophia, of course, who's just started a few months ago, is now part of this project with me, and a few others. Paige DiPolo is part of this project now as well. And we are doing a lot of work, field work, and also working in museums, trying to understand what happened when the dinosaurs died. In New Mexico, we find a lot of dinosaur bones. Then there's the extinction layer. Then the dinosaurs are gone. But now, all of a sudden, there's a whole lot of a new type of fossil, of these kind of fossils. And maybe you can sense what these are. I know some of you know what these are very well. But we all have things like these in our own bodies. So these are teeth. And they look pretty similar to our teeth, and that's because they are the teeth of mammals. It's the mammals that took over after the dinosaurs died. The first mammals evolved with the dinosaurs in the Triassic. But when the dinosaurs became big and spread around the world, the mammals remained small and humble and living in the shadows. But then the extinction happened, and within a few 100,000 years at most, you now have all kinds of new mammal species spreading around the world. Some of them are almost as big as cows. Some of them are diggers. Some of them are fast runners. Some of them are saber-toothed flesh eaters. Not, of course, saber-toothed cats, but things called triceratops, the wolves of this period of time. And there's another type of mammal, a small mammal, only about the size of a house cat, with long arms and long legs. It was kind of funny looking, this mammal. But it also had opposable thumbs, and it could swing from the trees. And so what we're looking at here is one of the very first primates, one of our ancestors living so soon after the dinosaurs died out. So that shows that it was the extinction of the dinosaurs that changed the world and set the stage for us. So we would not be here having this discussion if that asteroid didn't hit. And I think there's also a deeper lesson, though, and that is returning to this idea of dinosaurs as an empire. That empire did rise very gradually. It was very successful, and then it fell very suddenly. 150 million years the dinosaurs ruled the world, and then literally one day, the climate, the environment changed so quickly that their empire fell. Now, our species, we've been around for only about 200,000 years, very little compared to the dinosaurs. And now our world is changing very quickly, the climate, the environment. So I think we need some humility And we need to remind ourselves that if something like this could happen to the dinosaurs, maybe, if we're not careful, something like this could happen to us. And so on that cheerful note, I will end this talk. Thank you all very much, and I'm very happy to take questions and, of course, to sign as many books as you want. They make great gifts for Christmas, for friends and family and everybody, but I'm very happy. Take questions, sign books, anything that you need. So thank you very much. Grazie. Okay, I'm not sure the easiest way to do questions. I'll leave this up to Anna, the boss.
Sono domande? Laggiù in fondo.
You can bring this out now.
Prima delle domande però...
Prima? Mi fermo qui allora.
No.
Scusa.
This is just a little present from the two societies, from Appi,
Appi.
she was giving you that, and from the Geological Society.
All right. Grazie. Thank you.
Prego.
Very good.
Chi aveva la domanda?
Fantastic.
Scusa.
Love it.
We talked before about the bizarre coloration of feather dinosaurs, but I know there are many theories about the bizarre coloration even of the early dinosaurs. Someone theorized pink Triceratops or even yellow Tyrannosaurus. So what's your idea about that? And do you think even earlier dinosaurs like Jurassic or early Cretaceous dinosaurs maybe could have bird-like habits or social skills?
Yes, okay, very good question. So the second one I'll answer first. So yes, I think a lot of dinosaurs, even the oldest dinosaurs, probably were very much like birds, more like birds than they were like reptiles. So they probably did have some of the same behaviors as birds. And certainly some of the more derived dinosaurs like Velociraptor were basically birds. If you saw one of them, I think you would just think of it as a bird. No weirder than an ostrich or an emu or something like that. Now for the first question about the colors, so people have only known this for about 10 years. And so it's in a very early time of study. And so maybe 6 or 7 dinosaurs have been studied in this way because you need really well-preserved feathers to see the color. And so we know that some of these dinosaurs were black, some were brown, some had white feathers, some had red feathers, some had shiny feathers, some had different patterns on their bodies, some were camouflaged so they would fit into their surroundings. And that's what we know so far. We don't have any evidence yet that dinosaurs were pink or yellow. They could have been. I think any colors birds have today is reasonable to think maybe dinosaurs had these colors, but we don't yet have direct evidence from fossils for that.
Hello, you say that the T-Rex was the most biggest predator in the late Cretaceous era, but I know there were a lot of other predators like Giganotosaurus, Acrocanthosaurus, and other theropods that were bigger than the T-Rex. And my question is why the books didn't talk about other predators like this, but only of the evolution of the T-Rex, like you know, like it was the most biggest and important. Then this is my question. Thanks.
Yes, so there's many rumors and legends out there about theropods bigger than T-Rex. There's definitely one that was bigger than T-Rex, which is Spinosaurus. But Spinosaurus was a weird theropod. It spent a lot of its time in or near the water. We know that it ate fish. And so it wasn't really a pure land-living predator in the same way as T-Rex. Now, there are other dinosaurs that people sometimes say are bigger than T-Rex, like Giganotosaurus or Carcharodontosaurus. These were the dinosaurs that I studied when I started as a student, working with very famous paleontologist Paul Serino in my hometown of Chicago. And these are big dinosaurs, but they're not as big as T-Rex. They maybe are as long as T-Rex, but they're not as heavy as T-Rex. T-Rex is bigger, thicker, has bigger muscles. So I think there were many types of theropods that got close to the size of T-Rex, but as far as we know, there was nothing other than Spinosaurus that was definitely bigger than a T-Rex. But maybe somebody will find one, and then I will have to change this chapter in the book. A little bit smaller, yeah, but almost the same size.
I would like to make a question about evolution of feathers and evolution of wings in order to fly. You only correlated the switch from likely adaptation for display instead of that for fly to the smaller size of the body. I was wondering if you have been able, or shouldn't have you found something like a type of bone that would resemble more the bones typical of birds, like lighter and with some sponges structures inside?
Yes, so, of course, modern birds have very light bones, and this is important for them to be able to fly. If they're too heavy, you can't fly so easily. And also, the reason they have the light bones is because there's air sacs that come out from the lungs and hollow the bones out, and those air sacs are part of the system birds use to breathe very efficiently with their very special lungs. Now, we know that a lot of dinosaurs had that same system, so a lot of dinosaurs had hollow bones. And that means they would have had the same lungs as birds, which were very efficient at getting a lot of oxygen, and also that they would have had lighter skeletons. So Velociraptor is one example. So not all of the bones of Velociraptor are completely hollow, but a lot of them are. So it looks like dinosaurs evolved this earlier, before they started to fly, just like feathers and wings. So it's another system that dinosaurs needed to fly, but they evolved it for other reasons, probably in order to breathe better, because these lungs are more efficient. But this is also some of the new information, that's been coming out, which I think is very, very interesting. Marco,
Steve?
Yes?
It's me. Asteroid is blessed, so we can talk about mammals.
Yes, let's do it.
Do you find the same mammals in New Mexico below and above the KPG boundary or not?
No, we don't, except for maybe one type of multituberculate. And these are these, strange extinct mammals that were kind of similar to rodents, but were not closely related. In New Mexico and also in other places in western North America, like Montana, Hell Creek Formation, there's a lot of mammals that are there in the latest Cretaceous, but they were all small. And most of them were multituberculates or metatherians, so part of the marsupial group of mammals. There were very few eutherians, the ones, in the placental group. Then the extinction happens, and then most of the metatherians disappear. And a lot of the multituberculates do too. And instead, afterwards, you start to see a lot of new eutherians, including what we think are proper placental mammals. But there's still a lot of mysteries here. And we still know very little about this, which is why I hired Sophia to be part of this project. So Sophia was, Marco's student in Perugia before coming to Edinburgh. So I think for me, I love dinosaurs and continue to study them, but I think this is really fascinating. This is why I'm starting to work more on mammals, because I think this is a moment of evolution that was so dramatic and so important that we can learn a lot from. But we don't quite know all the answers yet.
Okay, thank you. My question goes back to your site in Scotland, the footprint which were left in the beach. And have you tried to cut the sediment to see how thick the mud is? Yeah. This is because if you look at the proportion of the size of the dinosaur is so big, and they are walking on this mud plane, so it could be the other interpretation could be this was a place where they stuck and died. Maybe this is my question.
Yeah, no, good question. So I'm sure you must, you know, the Olduvai Gorge footprints, you must spend time looking at these amazing human footprints. And, you know, every type of footprint is different, a different type of sediment. And so, yes, you have to understand the rocks really to understand how the footprint was made. So for those footprints there, they're found in kind of a sandy but also limestone type layer. It's like a calcareous sandstone. And, you know, we can tell from certain things, you know, some of the sedimentary structures and other things, that there was very shallow water when they were formed. Not deep water, I mean, maybe just a tiny little bit of water. And the layer is not so thick, but it's thick enough that you could have the tracks of big animals. So something like this. And then there's other layers beneath it that have the under tracks, you know, where the weight of the footprint would be transmitted to the rocks below. And some of the layers above it have mud cracks, so we know that then the lagoon dried out. So from the sedimentology, we can start to understand the environment a bit more. So we work with the sedimentologist who knows much more than I do about these things. But yes, to understand footprints, you need to understand the rock.
About a few days ago, I read about a bird discovered in China with well-evolved air sacs. And I would like to ask why dinosaurs evolved these air sacs, and also if dinosaurs, I don't know what to say. If, for example, Archosaurians or pterosaurs had these air sacs.
Yep, great question. And I know you know all about air sacs. I know you know about air sacs from the previous question, but maybe some of you haven't heard this term before, air sac. It's basically what it sounds like. It's a bag or a balloon full of air inside the body of a bird. And these sacs connect to the lungs. So birds have very different lungs than we have. And bird lungs are very efficient. Bird lungs bring in oxygen when the bird breathes in, like we do, but also the bird gets oxygen when it breathes out, which sounds impossible, right? It sounds impossible. But the reason this happens is because when the bird breathes in, some of the air with oxygen goes to the lungs, the rest of it goes to the air sacs. And then when the bird breathes out, the lungs from the air sacs go across the lung. And that air still has oxygen. So the air sacs are a fundamental part of this very unique type of lung. Now, birds have this lung, and traditionally people used to think, okay, birds evolved this lung because they are flying, because they need to bring in more oxygen, because flying is so difficult. But the discovery that a lot of dinosaurs had these air sacs changed that. So we know that a lot of dinosaurs had air sacs because the air sacs leave marks on the bone. And the air sacs go into the bone to hollow out the bones. So we can tell from dinosaur bones that they had this air sac system. It's not only Velociraptor and those kind of dinosaurs that had it, but many dinosaurs did, including the sauropod dinosaurs, the big long-necked dinosaurs. They had air sacs. And those air sacs helped to lighten their bodies, which was one reason they were able to get so big. Now, also, we know pterosaurs had these air sacs from their bones. And recently, people have found some evidence in modern crocodiles that some parts of the lung are very similar to the lungs of birds. So it's looking like, I think, that maybe this lung evolved long ago in the ancestor of all archosaurs. So long before birds started to fly. And it probably was one of the things that helped dinosaurs and crocodiles be very successful. That's what I think, but there's a lot of new discoveries, like you say, just these new ones just found, that are helping us understand this. I think only 1 or 2 modern crocodiles have They don't have air sacs, but they have this type of lung that is only one direction. Very peculiar, yeah. But this, I know not so much about modern crocs.
I was willing to ask you that in the beginning you said that a dinosaur coexisted with the crocodile-line archosaurs. So back into Triassic, bird-line archosaurs, so dinosaurs coexisted with the croc-line archosaurs. But is there a reason why were the crocodile-line archosaurs that dominated in the Triassic instead of bird-line dinosaurs?
Yeah, no, that's a great question. Why was the Triassic a time when these crocodile-line archosaurs were so diverse and the dinosaurs were not? I mean, there were more species of the crocodile line. They had a greater diversity of their body sizes and their diets and their behaviors, and they lived in more places and they were more abundant in the ecosystem. So really it was a crocodile world. Why? I don't really know. That's another mystery. Yeah, why did the first dinosaurs not become diverse right away? What allowed the crocs to do it? Don't know. I would love to know. So that's another question, I think, that has to be solved by somebody in the young generation. So, come to Edinburgh. Let's figure it out.
If I can have a question, I take advantage from my position here with the microphone. A question about crocodiles, I take the microphone here. Why they survived 66 million years ago, together with turtles, lizards? This is a mystery too.
Yeah, so when the asteroid hit, all these dinosaurs died except for birds. But in fact, most birds died as well. It was only a few birds that survived. It was the birds that had beaks, that could eat seeds, the birds that had big wings and could fly really well, and the birds that grew really fast. Mammals survived, but like we were talking about, not all mammals. Actually, there were all these marsupial-type mammals that lived with the dinosaurs that most of them went extinct. So it was only some mammals that survived, and the mammals that survived tended to be the ones that were smaller and that could eat a lot of different foods. So they were basically these disaster animals that could thrive in the chaos. And then some other things survived, of course, crocodiles, turtles, like you say. And more of them survived than the mammals, and more of them survived than the birds. Hardly any of them went extinct, and this was a big mystery, but I think there's a good explanation, and that is that when the asteroid hit, you had all this dust and dirt and rock that went into the atmosphere, into the currents in the atmosphere, and it would have blocked out the sun for, maybe a few years even. And this led the Earth to become very cold and very dark. This was a nuclear winter type of situation. And so plants could not photosynthesize, at least not very well. So you had the forests collapsing. And the same in the ocean with the phytoplankton collapsing. And so animals like dinosaurs and mammals and birds that were part of these food chains that depended on plants, they were hit very hard by the extinction. The crocodiles and the turtles, they more lived in rivers and lakes, and their food chains did not have plants at the base of the food chain. Instead, they were part of food chains that had detritus at the base. So detritus is just kind of the, garbage essentially, all the decaying stuff, leaves and other, organic matter that decays. And so that means that when all those plants were dying, crocodiles and turtles, their food chain would actually have a lot of food. And so I think this explanation makes a lot of sense. It might not be the entire explanation. Maybe they also got a little bit lucky. But I think this is probably the best explanation that I've heard of.
Altre domande? Bene.
Okay.
Allora ringraziamo il professor Brusatte per la disponibilità. E grazie a tutti voi che siete intervenuti. È disponibile per firmare i libri se li avete acquistati.